streaming. Start recording. Okay. And we are live, Jeff.
We are.
We are live. We are live on YouTube.
Oh, I gotta still press go live. Oh, you're live.
We are.
I was gonna say we're not live. I'm not live yet.
We kind of are.
You recording already? I'm gonna go ahead and press record on mine just so I don't forget to do it.
Yes, we are.
And I'll tell people. Hopefully we get a good group here since we've got so many good speakers this time.
Indeed.
Not like we haven't had good speakers, but I need to actually pull up my other link here. 1 minute left. Get to it, Jeff. Find it. That's not it. That's not it either. Didn't get very much play on my my share. There it is. All right. Okay, and we are going live. Here we go, buddy. Go live now.
Oh,
All
what
right.
is going on here?
Hopefully there's somebody coming in. There's somebody coming in. David, you're live with Jeff and Chris. And there's Robin. Got a couple of people here. We'll wait a couple minutes to see if the peanut gallery fills up. By the way, folks, we are recording this session a couple of different ways. Even though LinkedIn doesn't allow us to record, we are recording. So you are being recorded. Leave now if you don't want to be recorded, or just stay silent and you won't be recorded either. Feel like we need to make that painfully obvious, given that we're a privacy-focused show.
Yeah, it'd be ironic if someone found out later. It's like, hey, I didn't want that. And this is a quote-unquote privacy show. And you just doxed me.
Yeah, that would be bad. That would be very bad. There's David Kruger.
Yeah. What's funky is, so we're streaming live to YouTube, and for whatever reason, YouTube decided it wanted to default to our last live stream. So it called it US CBDC forum. Interesting.
Yes.
So
Yeah, that turned out really great. If any of you missed it, probably most of you missed it, but Chris ran a forum on
central bank digital currencies, indeed. Yeah, but I got so much demand afterwards from people that missed it. There was like 150 people or so registered, and then half of them couldn't make it for some reason.
Well, it was like a 4-hour forum, but it just flew by. It was amazing. We had like 20 speakers there. It was crazy.
Yeah, almost. Yeah. Yeah, surprising that such a nerdy topic created such engagement. I didn't expect that at all. I wanted to have a casual discussion on my thoughts on the topic. But anywho.
But that was a lot of privacy focus there, even though it was wide ranging.
Yeah, I mean, it's a big topic on all of the papers that they publish. So at least they realize that it's a problem. And as you may or may not have seen, there's actually people in Congress that want to kind of preempt this. the entire
What,
topic for
yeah,
privacy concerns specifically. But then also, as you probably saw, the European Union just passed something entirely bizarre.
Yes. Well, let's not get into that yet. Let's
Nope.
talk a little bit about encryption,
Yeah.
since that's
Yeah.
our topic.
Yeah. Maybe a little format for anybody who hasn't taken part in one of these Friday meetings yet. This is our 6th meeting, and initially we started this because Jeff got an invite to what I call LinkedIn's Clubhouse feature. So this is very much similar to Clubhouse, but only a very few select people, like Jeff, who is very special, got an invite to the alpha of that. So it's still in alpha stages. That's why sometimes strange things happen or things don't happen, which when you want them to happen, i.e. We ask people that want to join the actual discussion to raise their hand, quote unquote. What options do we have? Okay, I see we have reactions limited to thumbs up, something that looks like crying to me, something that looks like, what is that, Jeff? Is that praying? And then a heart. Well, so which one do we want to pick for requesting to participate? How about the hand thingy with, what is that? Celebrate. Oh, it tells you. Okay. Funny, like, heart. Okay. There's no raising hands. So I'll say we're gonna use the like button for people who want to join the actual discussion. So if you see the react emoticon on the bottom, just use the thumbs up thing and we will elevate to you to a talking person on the screen here.
Yeah. But to sort of get this rolling, we're going to have David Kruger sort of start off. David is with Absio, and he's written a bunch of different content. He's pretty well known here on the LinkedIn platform. I was particularly taken by an article he wrote about the physicality of data, which I shared on the post, and some of you may have read. But I think David's going to give us a little primer on encryption for anybody who's not quite there yet, and tell us about Absio and some of the great stuff that it can enable for us. And then I think we're going to go and talk with Robin Meyer at TokenX. And after that, we've got a couple of other speakers in store, or at least one more. So let's go there. David, you want to start us off?
Yeah, I'll start. Are you guys hearing me okay?
Yeah.
So what I thought I'd do, going back to Chris's comment about nerdy topics, encryption is about as nerdy as it gets. And being in the encryption business, we find that there's a lot of sort of misinformation, disinformation, and hype. So before I talk about what we do, I wanted to take a quick run through with some of the sort of the common problems and misconceptions and things to be dealt with that need to be dealt with in the world of encryption, and then we'll finish up with a couple minutes on what we do, and then just Q&A after that. So I'll go as quickly as I can here. So first of all, to what Jeff said, we do view the world of data as physical. As far as I can tell, there's, Hermione and Harry and Hagrid, all characters, sorcerers, are not on your phone, right? Or not on your laptop or PC. Data is physical. It's controlled by the laws of physics. It's created by the laws of physics, stored in accordance with the laws of physics, in all of that, right? It may be in the binary information that's in the form of radio waves or light waves or magnetic particles or pits on a DVD, but it is inherently physical in nature. And the reason we think that that's important is that anything that is physical, whether we can see it or not, we can control, right? And the point of cybersecurity and digital privacy is to control the creation, the use, the storage, and the data of real physical data. Does that make sense, Jeff?
Yeah, absolutely.
Yeah, so that's kind of the approach that we take. So what I want to start off with is limits and problems here, because there's a lot of hype and a lot of marketing speak around what encryption does, and it's not some magic salve that you can, massage into your cybersecurity or privacy boo-boo and everything will be all better. It doesn't work that way. So first of all, primarily encryption only protects data that's in storage or in transit. Right? Data has three states. It's either in storage, it's in transit, or it's in process. So encryption only protects 2 out of the 3. The exception to that, when I say that, people will always bring up homomorphic encryption, particularly fully homomorphic encryption. There's a partially homomorphic encryption, but that's sort of the pot of gold at the end of the rainbow. And fully homomorphic encryption means that you can encrypt data, and then in order to process it, you don't have to decrypt it. And that has been theoretically theoretically demonstrated. The problem is that today, hype notwithstanding, FHE, fully homomorphic encryption, is extraordinarily expensive computationally, and it's very, very slow. Particularly if it has to deal with any kind of large masses of data or large masses of unstructured data. So again, it's in a lot of ways the pot of gold at the end of the encryption rainbow. But we are, who knows? There could be some kind of breakthrough, but we are many years or maybe possibly many decades away from fully homomorphic encryption from being generally available, a thing that's just installed on your device or in your software when you get it. So great place that we want to get to, but we're a long way from getting there. So I kind of wanted to smell sort of some of the hype that's growing up around that.
Do you want to explain homomorphic encryption, like just the term homomorphic, David?
Pardon? Say that again, Christian?
Do you want to explain to people in the audience?
Oh, yeah. Homomorphic encryption is basically, it's the ability to process. You encrypt something, but you don't have to decrypt it in order to be able to process it. Right? In other words, you encrypt the data, preferably at creation, and then it's never decrypted again for any purpose, for whatever, because you can process it while the information is encrypted. Every other kind of thing that you do with encryption that you do with information, other than fully homomorphic, you have to decrypt things in order to process it. So something can be stored on your computer, encrypted, but you have to decrypt it in order to be able to use it. And while it's decrypted, it's vulnerable, right? So the only solution for that right now is fully homomorphic, but encryption, but it's not ready for prime time and probably won't be for many years. So that's, other than fully homomorphic encryption only controls data that's in storage or being sent from point A to point B. It doesn't protect it when it's in use, right? So not a thing that encryption does. There's a lot of, and I'm going through some of the problems here. There's a lot of reliance on third-party digital certificate agencies, Thought, and people like that. That's becoming more problematic as time goes on because of these third parties who we rely on to issue a certificate that associates an identity, the identity of a person or the identity of a company or the identity of a piece of software with a particular public key. When you're using public key encryption, they have become less reliable over time because they act as this certificate that you can trust that says, oh, you can download this piece of software from this company and because it's own good. Those are becoming less trustworthy over time, right? Another thing we hear a lot about that's one of these sort of magic salve type of things is full disk encryption, and probably one of the best known cases is BitLocker. Now it comes with Windows, and full disk encryption is good stuff. I mean, it's a good strategy, but it's limited because it essentially only protects the computer when it's off or when the computer's user is not logged in. There's a single encryption key that's held in memory. When you use BitLocker, you log in, you have to put in depending on what you do, your password or your phrase, and then it unlocks the hard drive so that you can do work. Well, if you have issues like malware has been installed, data stealing malware that's been installed on your computer, if you log in and use it, that malware can be operative. Right, or if somebody compromises your credential, they can get all the data off of your computer. So full disk encryption is a good thing to have, but it has limits in what it can protect, and people need to understand those limits. And unfortunately, when you look at some of the sort of the marketing hype around that, you would think from reading it that if you've got disk encryption turned on, you're golden. And that's really not the case. Fantastic if your computer is stolen. Other use cases, not so much, right? So that's a thing to be aware of. Another problem that is not here yet with encryption, but it is probably inevitable, and that this goes along with quantum computing, which I'm sure everybody here has probably heard of and read a little bit about. Along with quantum computing, you get quantum cryptanalysis, which basically cryptanalysis is just a term for being able to use mathematical techniques to be able to defeat encryption. Right, and the big concern with quantum computing is that things like public key encryption, symmetric key encryption, all can be defeated once quantum encryption becomes a reality. So a couple of things to think about that. That's probably true, right? At some point in time, quantum computing is going to become more generally available and more powerful, and it is likely that it will be able to defeat some of the current encryption algorithms and methodologies that we use. So a couple of things about that. One, organizations like NIST are working on quantum safe encryption techniques. And that's a bit of a horse race, right? We don't know if those techniques are going to be in time to stop a wave of hacker type decryption of content of all sorts. When that day finally comes, when quantum cryptography, when quantum computing enough and powerful enough to defeat whatever the current encryption algorithms are. That's a thing that's looming out there in the future. We don't know when that's going to happen. And there's been a lot of press on that, but one of the problems that there has not been a lot of press on this coming quantum computing revolution is the problem of immutability. And this is really a problem primarily in blockchain technology and distributed ledger technology. In a blockchain, again, not going to get into the details of it, but there's level 1 and level 2 type of blockchains, where level 1 is where you're actually, in this particular context, is where you're actually trying to protect the security of data, make data secure by storing it on the blockchain itself. And where the quantum cryptanalysis becomes a problem. Is that if you're storing something that's immutable, that you can't update the cryptography for, that you can't change to a quantum safe encryption algorithm, eventually that information that's stored directly on the blockchain is going to be decrypted, right? And depending on the blockchain application or cryptocurrency application, that can be a problem. Again, people that are in the blockchain and distributed ledger business, they understand this. Some of them are doing the things necessary to solve that problem. Some of them are not. Some of them are going to the layer 2 solution, where your data that has to be secured for a longer period of time, for a known period of time, where the encryption algorithms can be updated. So when you're looking at the kind of technology, that's worthwhile taking a look at. Yes.
Yeah, David, you've me say this before, but most people in the audience probably haven't heard me say that before. So from an investor's perspective, I look at this as in if and when and where you're actually storing anything on a blockchain-based solution, on some form of decentralized software solution that results in a quote-unquote immutable record, what you're actually doing, I call it, you're violating the herd immunity of your dApp, right? Because now you actually can't comply with certain laws and regulations anymore. Almost instantly, right? So
I have heard you say that. I'm glad you say that. Unfortunately, Chris, not everybody makes those distinctions.
I know. So that's why we will actually publish a separate article specifically on that topic, because we see this basically on a daily basis, right? Where dApp developers do exactly that. That's why it's such a bad analogy when people comparing blockchains to databases specifically, because the purpose of a decentralized software solutions, including blockchains, is not to store anything, right? The purpose is to move control over a set of bytes from A to B, and that's it.
Yeah.
There's nothing more there. So the immutability always just refers to the immutability of that state engine, right? So that we record the honesty of the nodes at any given point in time. Anyway, I'll let you go on.
No, I agree with you wholeheartedly. But very quick search will find people saying, keep your data safe and secure forever, stored on a blockchain, which just makes me cringe, right? And I know it does you too. So, but that's just something that's sort of a caveat emptor. Beware when people talk about secure data storage on the blockchain. So those are some of the problems, just some of the limitations to be aware of. So one of the things that we think is if you're going to use encryption and you're really going to protect your data, and again, I'm just limiting it to data in storage and data in transit, right, is to encrypt things by default. We as a company can't figure out why anybody would do anything other than that. So when a piece of software creates a piece of data, there is no good reason that we can think of not to encrypt that data by default. Very little of the data that's out there that exists, that's stored on various end devices and server everywhere, is intended to be public. If you have your own encryption keys, or you can control encryption for yourself, if you want to post something that you want people to find public, like say information on your website, you can always decrypt it. Unfortunately, the vast amount of data that exists out there in the world today, a lot of it very, very sensitive, is not encrypted. Right, or it's been shared so many times, copied so many times that the originator of the data has no idea where that data exists anymore. And if it exists on somebody else's system, their system won't encrypt it. So we believe that the solution to that is to enable the software that's creating and managing data to just encrypt it by default. Right, do it first right out of the box, and then only decrypt that information when it needs to be processed, period. There's also a technique called granular encryption, again, that our company uses and did some pioneering work. And basically, rather than doing something like full disk encryption, where you're just decrypting something when it's in storage and turned off, every individual data object, and again, these are physical data objects. I'm talking about every individual file or row in a database, or cell at the, even a cell level in a database, encrypted with its own unique key, and do it at the moment that it's created, and only decrypt it for use, and then decrypt it temporarily. Right, so we believe that granular encryption is a much more secure approach, and in doing it by default is a much better approach. So there's also a cryptographic authentication problem, and this is a general problem. I'll take just a minute to discuss here, just so that people are aware of it. When a computer does work, right, there are always three actors involved. There's a user, right, and a user will issue some kind of instruction to the computer. It'll either be typing information into a piece of software, it will be telling the software to move something from point A to B, or take a copy and transmit it to destination, Z, and so forth. So you've always got a user as one actor. Then there's the another actor is the software that the user is instructing, right? That particular instance of software on the particular device that they're using, and then that software obviously is installed on an instance of hardware. Sort of the problem from a cybersecurity and privacy, compromise any one of those three actors: the user, the software, the instance of software, the instance of hardware. Your cybersecurity fails or can fail, or your privacy can be violated, right? The problem is, in general, nowadays, we only authenticate the user. We don't authenticate the software. We don't authenticate the hardware. That creates kind of where attackers move through every day, right? They and this is one of the reasons why cybersecurity continues to fail, right? Why we continue to have so many problems with them. So authentication is sort of chronically insufficient. And again, for anybody who's in the cybersecurity space as well as the privacy space on this call, that's not going to be a surprise, but it's a thing that we need to solve, because and this is where encryption comes into to play. We already can cryptographically and do cryptographically authenticate users, but we don't cryptographically authenticate the software and the hardware. And to solve these privacy and security problems long term, we need to start doing that. So a little bit about Appsio technology, and then I'll wrap up here. We don't use a third-party certificate authority because of the problems that I talked with that. We're self-certificated, so we don't have any reliance on a third party. Our cryptography is updatable. We encrypt things by default. We use granular encryption. And we use a particular type of encryption technology called software-defined distributed key technology. So our encryption that we provide is implemented by software developers in the software itself, and it will work with any kind of software architecture because the keys are distributed. They're made by the application itself, so that the data can be encrypted at creation, and it can be managed by the software and by the user throughout the rest of its life cycle. We also attempt to solve the data protection in process problem. We cryptographically bind controls to the data objects themselves, right? And those controls enable the software developer to provide its users control over who, on what devices, where geographically, when, for how long, and for what purposes data can be used. So where Appsio is unique is that we use these cryptographically bound controls in order to be able to allow the user, the owner of the data, say it's personal information, to be able to control the use of their data throughout its life cycle, no matter where it is, right? And our goal is to enable delivering real privacy, real choice over how the data is used, as well as real cybersecurity at the software application level. And the reason that we do that is that if there's one thing that I think we've seen proven over the last couple of decades, you can't put enough point solutions. You can't implement enough cybersecurity measures or privacy measures to solving one problem at a time in order to be able to close all of the holes, all the different ways that cyber attackers get access to data, or the way our privacy is violated. Our view of the world is you can only effectively do that at the application, at the software level. So that's where we work. We enable again, not only for applications that use our technology to keep the data secure in rest and in transit, but we enable them to control the use of data throughout that data's life cycle. So that's sort of our view of things and what we do, and I'll shut up now.
All right. Thank you, David. I think we're going to talk much more about these particular topics. So at the end of the day, I think what we're going to look at in terms of topology for the web, it's going to be what I call mapped cryptographic primitives overall, right? And we're a long way towards that. But maybe we'll reach out to Robin and let her introduce herself to everybody and express what she is working on these days.
Good afternoon, everybody. So I am general counsel at a company called TokenX, and we do data tokenization, which we don't want to ever recommend data tokenization in lieu of encryption, but it's in addition to encryption. And of course, we have encryption at rest and in transit, like David just described. I thought it was super interesting what David talked about, granular encryption. I thought that was really interesting. What we do is tokenize at the data element level. So for instance, you go to the Ritz-Carlton and they say, how about you give me your credit card number, your credit card for incidentals, and you put it in the machine. And a company like TokenX, and preferably it's TokenX, goes in between the individual and the Ritz-Carlton and takes for instance, the credit card number is easy example. There's a lot of other examples, but this is one we can all relate to. Takes the credit card number, puts it through an algorithm, and so depending on the token scheme that's been adopted, it leaves certain characters that are available for the business to use, to continue to use that number, but the rest of it has non-sensitive characters instead. And then the credit card number it doesn't exist anymore. It's like the movie Transformers. It goes through and transforms, and what comes out and what's delivered to the Ritz-Carlton is a token. So for instance, when we talk on the phone to a company, they'll say, what's the last four of your social? What's the last four of your credit card number? They'll ask us for a piece of data, and often that's because that's tokenized in their environment, and that's what's left available for them to see. So that's the primary gist of it. There's more to it. And if we get very much more technical, I'm not as technical as David, if we get very much more technical, I'm going to need a lifeline. But and I don't know if other people have heard of tokenization or not. Now we get a lot of questions. If are we talking about crypto? Are we talking about NFTs? What are we?
Yeah.
And
you're talking about tokens in kind of the original sense, right? I think that's actually still the definition you find on Wikipedia if you look up a token in this particular kind of security context.
Yes.
Or it's like if people have these kind of token generator thingies that you get for your keychain, some banks have those. That's also like predates what we call a token now in the crypto environment.
Right. And one of the most common use cases is payment card information, because if you tokenize the data, you're about 99+% compliant if you do that, and then there's a small subset of items that you still have to comply with. So that way I think was the original use case for it, but of course now it's structured and semi-structured data, and then our guys are working on something this year that will go beyond structured and semi-structured and open it up even more.
And so do you guys have an integration with the crypto space, or are you just purely focused on security in kind of the legacy finance space?
Right. So TokenX, we look at it as a security and privacy preserving tool, both. It's security, yes. If there's a breach, the bad guy just doesn't even see the data. So there you have that. But what's interesting about you asking about the crypto space, we are not in the crypto space, haven't been in the crypto space, but literally yesterday, our CEO, after, um, like Jeff mentioned in the LinkedIn post, we recently had a pretty significant investment by a company called K1, a really good investment partner. And yesterday, our CEO talked to the whole company, just talking about strategic goals and things like that. And he had what he called a big, hairy ass goal. And it had the word crypto in it, which highly excited me. I don't even know how that's going to play out. But it was pretty exciting just to hear that even talked about here for the future. So we'll see.
Yeah, I think what's largely lost in the current space of cryptocurrencies and tokens is the fact that every token is just a standardized smart contract, right? And it lives on top of an application. So blockchains are really not layers, they're not protocols, they're applications, right? And that's why on a daily basis we're trying to explain the difference, because these metaphors are not very helpful because they're leading you down the wrong way, right? You have to understand the overall developing topology of the web if you want to be a player on top of the web. Otherwise, what we're seeing right now, the entire space of quote-unquote cryptocurrencies is kind of self-insulating themselves from real-world economic activity because it really doesn't integrate with that. And if you already are playing on the level of data exchange systems right now, you're much better positioned, whereas others kind of play within their own ecosystem, unfortunately. I just got another phone call with the exact same discussion, right? Where people working on the actual protocol layer. That's why it's not helpful to call blockchains protocols. They're not protocols in the network stack sense. They are protocols in the business logic sense, which is a huge difference, right?
Interesting. Well, we'll see how it unfolds. It would be great to marry the two. I would love to see that, just because I'm personally, this is not the opinion of, anything I say here is not the opinion of TokenX, it's the opinion of Robin, but I personally have a lot of interest in the crypto space.
Yeah,
I mean, I would love to see the two come together.
Yeah, I mean, it has to exist. I mean, that's why we called this podcast "Your Bytes, Your Rights." From where I'm sitting, and Jeff is probably going to concur with that, is our bytes, or digital dust, how I call it, should have always just belonged to us, right? So I never saw a reason that there should be databases out there that have 20,000 records about me and then use it to profile me and social engineer me into doing something. I should have always been able to call this back. And unfortunately, I think a lot of the situation is just based on legacy technology, i.e. database implementations, that we let it come to that extent. So that's why we're doing these discussions, so to create more awareness for A, the state of technology, and then B, the fact that we actually can do something about it now. Right?
Right. I recently heard a podcast from the fellow who's one of the founders of Brave, which is, I guess, a privacy.
Yeah.
I haven't myself gone to it, but I thought the concept was really interesting. It sounds much like what you just described.
Yeah, it does. And with Brave specifically, it's kind of a go-to-market strategy fumble. Unfortunately, I keep installing and uninstalling it.
That is not good news.
I know. Well, and that's just the thing. So from a VC's perspective, obviously go-to-market is a very important aspect. And usually with me, you get a dozen chances because I'm an early adopter. Most people aren't like that, right? You have exactly one chance to get it right, to get out a solution that scales, that will stick with people. They don't uninstall it once or install it twice again. They usually install it once they uninstall it, they are done with you and they move on, right? So anyway,
it's like going to a new restaurant.
Yeah, exactly. Yeah, once you're burned, you're not gonna come back, right? Yeah, it's very unfortunate. But in our last discussion, and I'm trying to find my notes about that, Jeff, you might remember who said data is a toxic asset. That came up in our last discussion.
I don't
in
remember.
That academic paper.
I've said that a few times, but I don't know. I don't know who said it in our last discussion.
Yeah, it came up in the academic paper. It was actually a source. So I'm I'm trying to track down the actual author or who said that. All right, awkward pause here. Jeff, you're moderating.
Okay. Well, I wanted to next bring Dave Burnett up. I commented in our post that facial recognition systems need a map of your face, and that perhaps the most personal of personal data is your face map. But that those maps can those maps really be kept safe? Dave is from Infinity Optics, and Dave, if you will request presence, or I think you have to do something for me to be able to call you on stage, I'll pull you up there. There you go, allow to speak. And he's got some interesting technology that I've been trying to sort of think through and help them out with a little bit in the realm of facial recognition encryption. And I'll let him tell you about it. You'll have to unmute yourself first, Dave. There's a
Can you hear me now?
There you go. You got it.
Okay, awesome. Hi, I'm Dave Burnett, and I'm the head of business development at Infinity Optics. But I have a long background in security and privacy and authentication and identity, going all the way back to early PGP days. So this whole discussion about keys and encryption is near and dear to my heart. And you know, I kind of building off of something that you said, Chris. Having done a lot of biometric implementations on mobile devices and PCs that are the things that we entrust with our data. I'd like to put out not that data is a toxic asset, but that our encryption keys are in fact the toxic asset, and they are necessary. But what if your bytes and your rights could be linked to your bytes, your rights, and your confirmed presence, so that your keys don't exist, your decryption keys or encryption keys do not exist unless your physical presence has been confirmed through some form of authentication. And we actually have that technology. And yes, it does other things, but at least for this audience, that's probably the most novel and most relevant part of what we do, which is we have the technology and the capability to. We work with multiple modalities. We're pushing and most promoting right now our face solution because that's very popular these days, and there's a lot of anxiety around theft of face recognition data. But our technology works with fingerprint and voice and other types of authentication. But at the end of the day, and I'll explain a little bit more about it in kind of from a kind of a simple orientation perspective. But we basically have the capability to generate a stable hash from your face data. And a hash, for those that don't know, is a one-way data transformation function that takes some data and turns it into a short string representation. It's not encryption. It's a one-way conversion that you can't reverse. And the challenge historically has been because every time you authenticate with a face or a finger, the data that's captured is always a little bit different. So you've never been.
Did we lose Dave?
I'm not sure. Dave, you still there?
Yep. Did I drop out? I didn't
Yes.
hear.
Yeah, you dropped out there for a second.
Just the last couple of sentences.
I'm not sure if it's the platform. I've got fiber, so I don't think it's me.
Yeah, I'm sure it's the
Can
platform.
you
Yeah,
hear me again?
this is an alpha version of LinkedIn's
Hello?
voice tool. Yeah, we can hear you. Go on, Dave.
Can you hear me?
Yeah, we can hear you, Dave.
Okay, perfect. Sorry, it sounded like I lost the connection there. So basically, we have that ability to take your biometric information and turn it into a hash that can be used as a seed for generating public, either symmetric keys or asymmetric keys. And thus, the only time you actually have a key present on your device is when you are present. And when your session with your phone or your computer goes away, then your key is thrown away. And this defeats a significant attack vector, which is, and full disk encryption was discussed previously, where, if someone gets a hold of your device, your key is there somewhere. And there are different levels of protection, and some devices do a better job of protecting your key when your data is at rest and your device is stolen. And some devices don't do anywhere near as good a job protecting your key. So we have a pretty radical approach. Just don't keep the keys. They're dangerous. You can't trust that all device makers will do an equivalent quality of implementation to keep those keys safe.
Yeah, and I should say we actually have an investment in that space. So the company that we invested in actually just got acquired, but it's called Keyless for that exact reason.
Yep, I'm well aware of Keyless. It's very, very similar conceptually. I think there are implementation differences, but yeah, it was a good acquisition for them, it looks like.
Yeah, SIFT bought it in November.
Yep.
So, yeah, for sure.
Nice. So it seems to me that we're seeing, I guess, sort of what David talked about, right? That encryption has a few problems, but there are certain use cases where either encryption in use or encryption on these edge cases, like what Infinity Optics or Keyless, or I mentioned a couple of other use cases, titanium and triple blind, where they're using actually like partially homomorphic encryption, where they're doing things that can actually do sort of encryption in use. I don't know, how would you label your stuff? It's not really encryption in use, Dave. Does it have a place?
Yes, I think it does. I mean, so our primary marketing messages are around authentication because, just like we don't, there's no need to preserve a key with our technology. We also don't preserve the kinds of typical data that are preserved by other, by traditional biometric authentication systems. Traditional systems, keep information about you both your, a kind of a map of interesting locations in your biometric data and what to find there. And then when it stores that information, which is sensitive information. And then when you come back and authenticate, it does a comparison between what it saw before and what it's seeing now. And just like I was talking about getting rid of your keys, because we're using zero knowledge proofs, and really we're only storing where to look, not what to look for, we have a far safer security profile. But at the end of the day, going back to the core thread of this discussion, is when with our platform, it's pretty straightforward to link our technology to other platforms, so that the only time that your data is decrypted is when you are present and your key is reconstructed. So it's very much about data in use.
So do you guys offer, Dave, are you guys offering some sort of SDK then for app developers to implement this?
Absolutely.
Okay. And where do you see the most usage for it right now?
So we're seeing, our focus is primarily on the authentication side, partly because it's a different audience and a smaller audience on the what we call it biometric encryption side of the house. But part of what interested me about joining this call was to talk to another group of security folks. So I'd say we just haven't really spent the time and energy to try to approach the crypto market. But to me, I think that's the more that's one of the more powerful scenarios because depending upon how much different people follow, all of many devices that have been reputed to be secure, whether it's Samsung phones or Windows PCs, in terms of protecting your keys, there's been a lot of information about how those devices have been breached, and keys, your keys for decrypting your data get leaked after the fact, and that's I think it's a compelling kind of second leg to the stool. It's just not been a focus area for us. Time and energy.
I mean, in the cybersecurity space, we have this saying as you can only protect what you don't have, essentially.
Correct. And we're very much believers in that philosophy. And that's one of, I think, it's one of the key challenges with the traditional biometrics framework, which is, biometrics are linked to key stores. And those key stores that have all of your private keys are only, they're only as secure as the implementation, and you have to trust the device vendor for protecting those keys.
So are you guys doing a liveness check, or you
Yes.
outsourcing? Okay.
Yes. Yep. We do liveness. We do liveness checks, and we basically build a map of your facial data. But of course, we're only looking for where the interesting places are, and there's what we call public code is the only thing that's kept, and our accuracy rate is extremely high. And so these public codes, not only are they non-identifying in that they don't have any personal data, they don't contain any personal data. It's very difficult to reverse engineer them. I mean, there's all sorts of security design that's gone into the core technology.
Nice.
Yep.
Okay. Do we have any questions for Dave, for Robin, for David, or anybody else that would like to come on stage and ask a question or talk?
Also, we're getting feedback from someone. So if you're not speaking, please mute yourself. Otherwise, we have a lot of background noise. I don't think we have moderator control on our end. At least I don't. It's a future feature. And thanks, Ken. Ken looked up the quote that I mentioned earlier about data being toxic. It was by Bruce Schneier, apparently, originally, which I seem to remember is the correct name here. And then also to Dave's point, so it's really what he is talking about is data sitting in other people's databases that shouldn't be there in the first place, so to speak. So our contention is that there's basically no database right now that doesn't entail doesn't contain any type of data that shouldn't have been recorded by this particular entity that has it in custody to begin with. And on that same note, Jeff has aggregated an enormous list of data brokers, and our personal objective is to invalidate all of those data brokers ultimately over the next 10 years, and hopefully sooner.
Yeah, that makes an enormous amount of sense. I think while much of what I spoke to was in a device-centric context, it's the core principles are the same, right? Why should whatever cloud service provider you're using for whatever reason, why should they have a copy of your key? They might have your data, but they don't need your keys. And your keys should never exist anywhere unless you're authenticated to be present. And it works the concept applies just as well to the cloud and cloud systems as it does to individual devices.
Yeah, and that kind of dovetails with the current regulatory requirements. So we've been saying this for a long time, kind of the request of CCPA and GDPR, the right to be forgotten, is entirely naive, obviously, if you're talking about digital technologies, because nothing that you have digitally observed can ever be forgotten. It's immediately copied, distributed, refactored. So the correct demand, as far as I'm concerned, is always, I, as a human being, have the unalienable right not to be observed to begin with, right? That's where it needs to start. But yeah, if you can even preempt this to where you don't send on certain data, where you kind of just send on a green check mark, that's what I call it. Let me know if you have a better metaphor for it. In the cases where that's needed, then that should be the default position. And I hope, and maybe someone in the audience can tell me how it works right now with the new driver's licenses that are being issued in Arizona, if and when and where I want to pass by TSA, if they still get a copy of my PII or if it's indeed a green check mark. Jeff, were you able to figure that out?
No, I wasn't able to figure that out.
I've looked at that a little bit, and I believe it's very use case dependent, right? So I believe, from looking at this about a year ago, that if you're going up to a bar, for instance, and you just want to confirm identity, age, that it can be narrowed down to just that data set, and just the thumbs up that you were speaking to, as opposed to a full-on transfer of all of your information. But this is an area too that there's, this whole move to digital identity, digital driver's license has potentially huge benefits and huge drawbacks, and I think we're just at the beginning stages of this. Not just this technical rollout, but how you onboard other providers other than Apple into this is very much in play. Whether Samsung and Qualcomm will build out similar architectures, also interesting questions there.
Yeah, which is something that might actually need to be implemented on the chip level itself, right?
I'm sorry, I'm hearing some shuffling paper. What was that, Christian?
Yeah, I think that's probably something that should be implemented on the chip level itself, right?
It should be, right? It absolutely should be, but that's been, for what's been clear for quite some time is that there's been, yes, about a year ago, Google started talking about secure elements and creating a platform for secure elements on Android devices. But up until that point in time, there was hardly a secure element on the device that didn't have to do with your SIM card. And it was basically all software-based security, which is why you've seen hacks of Samsung's secure environment, which is essentially Qualcomm's secure environment. So fully agree, it absolutely should be a secure element on the mobile device, but that's not the Android platform as a whole, and Android manufacturers, of which there are fewer, just have not put that kind of hardware investment into their devices.
All right, so we are 5 minutes towards the top of the hour, and I know Jeff has a hard stop, and usually I try to end it there as well. So maybe some closing remarks and opening it up for questions. We created a small group on LinkedIn at this particular point in time to aggregate requests and members. We will be doing this every Friday, at least Jeff and I are committed to doing this every Friday. We find it useful for us regardless, and we will be inviting people on a weekly basis to speak about particular topics that they dove into. And yeah, my particular daily focus is on quote-unquote identity solution. I say quote-unquote because what we're talking about, as far as I'm concerned, is always the topic of human agency, as in, am I directing myself and or am I leaving this to other people and or devices and or algorithms? And so for me, technology should ultimately be in the service for humans and actually empower humans. And I think we have done a really bad job in the context of network technologies to make that possible. So by and large, I think we are all non-player characters whenever we engage with these networked solutions, because unfortunately, they usually know more about us than we know more about them. And I think it's very critical that we reverse this particular paradigm. So that's the motivation for doing this. Nothing here is like self-promoting or anything else. It's really sharing thoughts for peer review and hopefully getting an interdisciplinary discussion going. So anybody who has good ideas or knows people who have good ideas, please send them my way or Jeff's way, and we'll have them on here. Jeff? Okay, Jeff, do you need to unmute yourself, or do you...
Yeah, I'm sitting here spouting
talking
knowledge
away. I figured as much. Yep.
spouting knowledge to myself, apparently. What I was trying to say was, I think we learned a few things about encryption and heard about some great solutions, but we probably also learned that encryption is probably not going to solve everything, at least not immediately. So I guess that's pretty much it for today. I want to thank our speakers, David and Robin and Dave, for their insights, and look forward to seeing a bunch of you next week. If you've got ideas for what you want to hear about, please comment on the posts or get in touch with me in other ways. And glad you could attend.
Yeah, and read David's paper. You should find this on our group page, right, Jeff? Did you post it there?
Yeah.
Okay.
Yeah, we'll post that, and we'll post some other material too, that if you haven't seen it, some information from Dave as well. I think that didn't get posted yet.
All right. Thank you, everybody. Have a good weekend.
Yeah.
Thanks, Chris and Jeff.
Take care. Bye.
Thanks, Robin.
Bye.
Bye.
Thanks, guys.
Bye, David.